With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states block A of mass 3 kg is placed on another block B of mass 5 kg placed on a smooth surface. So you can see two blocks here. The B is simply of 5 kg, A is of 3 kg, and they are placed on each other. This is smooth, and here we have friction. If the coefficient of friction between the two blocks is simply 1/2 or 0.5 and 32 Newton force is applied on the block B as shown in the figure, then the work done by the frictional force on block A in first 2 seconds will be, and we have to take the value of G as 10 meter per second square. Now let us try to solve this problem. Let us first understand what will happen to this system of masses. See, this surface is smooth. This is the smooth surface. So there is no friction force here. So this 32 Newton acting on this block B will accelerate this block, and here we have friction, right? So here we have friction and the coefficient is simply 0.5. Now you can see here, if this 32 Newton force is acting on the block B, so this will start accelerating and the combined system will move with some acceleration. Let us try to see what will be that acceleration first. Now the acceleration will be simply equals to the force, the net external force on this system of masses is simply equals to combined mass of the system into the acceleration of the system. Now here you can see that the net external force on these two masses is simply 32 Newton. So this is simply 32 is simply equals to mass of the system. Here we have to take B plus A. So 5 plus 3 is simply equals to 8 into A. So from here we find out that the acceleration will be simply 4 meter per second square. Now this will be the acceleration. So this will be the acceleration of B as well as A. This combined system will move with this acceleration A. Now let us try to see what happens with the first block. So if we try to draw the free body diagram for the first block, what actually happens is that two forces acts on the block. One is the mg, that is acting downward, and the other is simply the normal reaction. This will be the friction force. Let us find out the limiting, what is the maximum friction force which can act between these two blocks. So this is Fs, limiting friction force. Remember, this is the maximum value of friction. This is limiting friction. First we will find the value of limiting friction, and then we will see what will be the frictional force acting between the block. Remember that not always the limiting friction is simply acting between these two blocks. That depends upon the acceleration of this block and this or this system. So this will be simply the weight of this mass, smaller mass, and this will be the normal reaction. Since there is no motion, these two forces will simply balance out. Now let us try to find out the limiting friction force or the maximum friction force. This is simply equals to mu times n, and n is simply equals to mg. So the maximum friction force which can act is simply mu mg. Now let us put the value and we find the limiting friction force. This mu is 0.5, m is 3, and g is simply 10. So this is 0.5 into 3 into 10. So we get the maximum friction force is simply equals to 15 Newton. Now let us try to see whether the 15 Newton force will be acting on this block or the friction force will be less. Now we know the friction force is self-adjusting. So let us see what will be the inertial force acting on this block in this direction. So this block has acceleration A, right? This is the acceleration A, which is simply equals to 4 meter per second square. And its mass is 3 kilograms, that is mentioned in the question. So let us see what is the inertial force in this direction. So this will be simply equals to F is simply equals to MA. So let us calculate this force F here. So F is simply mass, which is 3, into the acceleration is 4. This is simply 12 newtons. So this is the force that is acting on this. Now we know that how much friction force will be acting on this, you can see that the maximum friction force which can act is 15 Newton. But since only the 12 Newton force is acting in this direction, so friction is a self-adjusting force. Then what will happen is that only the 12 Newton force will be acting as friction here. So the friction force, let us take Fs dash, this will not be equals to limiting friction force because you can see that this will be equals to the inertial force. So this will be simply 12 Newton. Now we have found out the frictional force acting on the block, right? So we have found out Fs dash, this is simply equals to the 12 Newton. Now let us find out the displacement of this block in 2 seconds. For that we can simply apply S is simply equals to ut, because this block will start from rest, plus half at square. So u is simply 0, so this entire term will be 0, and if we put the values here, so S is half into the acceleration is simply 4, and in 2 seconds we have to find the work done. So the 2 square is simply 4, so this and this will simply cancel out, this will be 8. S is simply equals to 8 meter. Now the work done, we have to find the work done during the frictional, due to the frictional force. So this is simply equals to minus Fs dash into the S that we have found. Now why we are putting a negative sign? Very clearly this is accelerating in this direction, so the displacement is in this direction, and the frictional force is in this direction, so the minus sign here. So this will be simply equals to minus, we put the values 96 joule. So this will be the correct option. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.